Today we are going to discuss about waters, okay, its physical properties, chemical properties. So we all know what is water. So water is forms a major part of all living organisms, okay. So it is a crucial component for survival of all life forms. So water, it acts as a solvent, okay, and sometimes it is called as universal solvent. And human body contains about 65% water, plants about 95%, okay. This is not the exact percentage, but it is about 65 and in human and 95 in plants, okay. So water forms a crucial part, okay, for survival of all life forms. Let us see some physical properties, okay. It's already given here. Physical properties, we all know, we are all familiar with the physical properties, okay. We use water daily in our life, okay. So we will all know the physical properties. It is colorless, tasteless, odorless, transparent liquid, okay. Now boiling point, we all know, we have been studying about the boiling point also, 100 degrees Celsius, okay. So why there is high boiling point for water? The reason is due to hydrogen bonding. So water exhibit hydrogen bonding, okay. There is high strong hydrogen bonding in water molecule. It has high specific heat, thermal conductivity, surface tension, dipole moment, dielectric constant. So specific heat, okay, the amount required to raise the energy, okay, of 1 kg substance, okay, by 1 degree Celsius, or let's say Kelvin, okay. So thermal conductivity, okay, they conduct heat, okay. Surface tension, okay. So the water shows surface tension, okay, due to cohesive force, okay, against external force, okay. So they maintain their own shape, okay, due to cohesive nature, okay. Now dipole moment. Dipole moment, so this dipole moment arises because of charge, okay, differences, okay, or negativity, difference in electronegativity. So this dipole moment measures the polarity of a molecule. So water is a polar molecule, okay. Dielectric constant, okay, it measures the polarity. Dielectric constant measures the polarity, okay. So the more polar a molecule is, the higher the dielectric constant. It is a universal solvent. So about specific heat, thermal conductivity, surface tension, dipole moment, okay, all those things in your different chapter or unit, you will be discussing on these things in detail. For now, this is we are not going to discuss in detail. Now, structure of water. So in a gas phase, water is a band molecule, okay, band molecule in gas phase, okay, in gas phase. So in gas phase, water is a band molecule, so it's slightly band, okay. So we all know the formula of water molecule, H2O. So O, it looks band, okay, band. So this angle is 104.5 degree, okay. The distance between O and H bond is 95.7 picometer, okay. So this is the structure of water molecule. So water is a highly polar molecule, okay. So let's check the polarity. So polarity arises due to electronegative differences, okay. We all know oxygen is electronegative element, so it will be delta minus, okay, delta plus. So this oxygen will pull electrons towards itself and attains negative charge, okay, or slightly negative charge, and hydrogen, since it has given, okay, electron is pulled towards from hydrogen, so it will have partial positive charge. So this is the reason why water molecule is polar. Now let us see the orbital overlap. So hydrogen has two lone pair, okay, two lone pair of electrons, okay, that means two electrons, okay, unpaired electrons, that means 4 unpaired electrons, okay. So this two, we call it as 2 unpaired electrons as lone pairs, okay. So 2 lone pairs of unpaired electrons. P orbital, okay, hydrogen H, okay. So hydrogen has s orbital, so this overlap, okay, with the p orbital, okay. So hydrogen, this is the orbital overlap, okay, orbital overlap of hydrogen water molecule. Structure of ice, okay. Structure of ice, usually ice, okay, they are crystalline, okay. So ice, they are crystalline in nature, okay. So at high atmospheric pressure, okay, the crystalline in ice is hexagonal, okay, but at very low temperature it condenses to cubic form, okay. High temperature or pressure, okay, atmospheric pressure exists as hexagonal form. Low temperature condensed to cubic form. So density of ice is less than water, okay. Density of ice is less than water, less than water. That's why ice, okay, or cube of ice, they float on water. Now X-ray shows that each oxygen atom, okay, X-ray shows that each oxygen atom is surrounded tetrahedrally by 4 other oxygen atoms, okay, at a distance of 276 picometer. Now I haven't drawn the structure, okay. Let us see from your textbook. So it's given in your textbook, okay. Structure of ice. So this bigger spherical structure denotes the oxygen atom, okay. So they are arranged tetrahedrally, okay. The smaller one represents the hydrogen, okay. So this is the structure of ice. So we have seen a somewhat tetrahedral structure, okay. So in that structure there are holes, okay, empty spaces, that means, okay. So in that empty space it can hold some molecules also, okay. Now we'll discuss about chemical properties of water. Amphoteric nature. By amphoteric nature, it means it acts as an acid and as well as base, okay. Amphoteric means a chemical or compound can act as a base or an acid, okay. It can show both nature. So amphoteric nature of water, okay. So water can act as a base and as a acid. So firstly, let's see water as acid. Ammonia, base. So according to Bronsted-Lowry concept, according to that concept, An acid is one which donate a proton. So this water molecule can donate a proton, okay, to this, and then water molecule will become OH minus, okay, since it's only one proton, and since ammonia molecule can accept, okay, so it become NH4 plus, okay. So this can accept a base, so it becomes a proton, so it becomes a base. Let's say another example in which water can act as a base, okay, and H2S. So H2S or hydrogen sulfide, this hydrogen sulfide can donate proton to water molecule, okay. In that way this water molecule act as a base. So this will become HO3 plus, this become HS, okay. Next is auto ionization. Self ionization, okay, self ionization or auto protolysis. So it means ionization, okay, self ionization. So let's say this one as a acid, this one as base, okay. So in auto ionization the same molecule will ionize, okay. So in this case this acid will donate one proton to this base, okay. So it will give H3O plus, okay, and then OH minus, okay. So this is known as conjugate base, conjugate acid, okay, the base. This will be conjugate base. So this again can donate proton, okay, this again can accept proton, okay. So this is conjugate base, that is why this is conjugate acid. Next is redox reaction. So in redox reaction what happen is oxidation reductions, okay, both oxidation and reductions takes place, okay. In this case the charge of hydrogen is +1, okay, and sodium 0, okay. So what is happening here is this sodium is oxidized, okay. Here sodium charge oxidation state is +1, okay, and this hydrogen reduced to H, okay, charge will be 0 here, okay. So in this case oxidation taking place, reduction, okay, +1 to 0, okay, oxidation, so it is reduced. So oxidation reductions take place. So water also exhibit redox reaction. Let's see another example, okay. In that example water is reduced to oxygen, okay, during photosynthesis, okay. 6CO2 plus 12 water molecule, C6H12O6, 6H2O plus 6O2. So in this case what is happening is this water molecule get reduced to oxygen, okay, it breaks into water molecule and oxygen, okay. So it is reduced, okay, during photosynthesis. So this is a reaction taking place in photosynthesis. Next one is hydrolysis reaction. So hydrolysis reaction, okay, we see hydrolysis reaction of water, okay, due to high dielectric constant, okay. So since it has high dielectric constant, it can dissolve many ionic compounds, okay. Let us see some example. P4 or 10. So water has the capacity to dissolve many ionic compounds due to high dielectric constant. SiCl4 plus 2H2O, SiO2 plus 4HCl. So this PO4 then converted to H3PO4, SiCl4 converted to SiO2 and 4HCl. Next is hydrate formation. So hydrate means attachment of water molecule to certain compound, or let's say complex. Okay, water molecule is attached. Okay, so in this hydrate formation, okay, the first case is coordinated water. So an example of coordinated water can be Cr H2O 6 3 plus. So in this coordinated water, okay, what is happening is 6 water molecule is coordinated or get attached, okay, to this central metal chromium. So this will be H2O, okay, H2O, 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 okay. That means 6 water molecule is coordinated to this central metal. So water can form hydrate, okay. That means attachment of water molecule to central metal or any other compound, okay. Next one will be interstitial water. Example is barium Cl2, okay, barium chloride, and then 2 water molecule. Barium chloride, okay. In barium chloride, what is the structure is crystalline, okay. They look like cube, okay. So this round or spherical shape represent the barium, okay, and chlorine can be here, okay, and water molecule can be in the space, okay. So this is called interstitial water, okay. That means water will be in the space or holes, okay. Suppose these are the molecule, okay, so water will be present in the space or holes, okay, empty space or holes. So this is called interstitial water. Next is hydrogen bonded water. So example will be CuSO4 5H2O, okay. In this case CuH2O4, okay, is coordinated to copper, okay. 4 molecule is coordinated to copper, okay. And SO4 2 minus H2O is outside, okay. That means this 4 molecule does not take part in hydrogen bonding, okay. Only this molecule, water molecule outside the bracket or coordination sphere take place in bonding, okay. So this hydrogen can form bonds with SO4, okay. So this is called hydrogen bonded water.